Okay, let's start. It's time to. Hello, everyone. Good morning, bom dia, dobry dzień, assalamu alaikum, buongiorno, bonjour, and welcome to this new webinar session organized by Ocrim. My name is Anna Buffa. I'm a food entertainer, and I work in the food communication since 15 years, and I will moderate this webinar. So I hope you enjoy it. Now some indication about the organization of this webinar. It will last 1 hour and including questions and answers time. You will be able to ask the speaker Marco Galli question at any time by accessing to the form you find in your screen, and will be 2 moments dedicated to the question and answer moment. After the first half of the presentation and after the second part to the final part of the presentation. The most complex question will be answered by mail. You can write us at a conference room at ocrim.com. Questions are anonymous, so don't be shy. You can ask everything you want. Today's topic is the first of a 3 technological session, but about this I will leave the word to our speaker Marco Galli. Now a few words about him. In the 1983, Marco began his career in Ocrim as miller apprentice. In the early 90s, began technology manager of the largest milling complex in Indonesia, the Bogasari flour mill. In the 2006, began Ocrim technology manager and headmaster of Ocrim Milling Technology School. And he's known for his continuous research of the new application in the milling field, having patented inventions filed in his name. Recently, he has managed the technological design of the new milling complex in Cremona, which will be built, which name is the Milling Hub. I'm very glad to introduce you, Marco. So I give you the word, Marco. Good morning.
Hello, good morning, good afternoon, and thanks, Anna, for the introduction, and a good day to all, and welcome again to this webinar. As already mentioned by Anna, I will try to share with you some technical aspects and that we normally use on the developing of our flow sheet. So I hope this can be helpful for you also in your working life. And I hope you will enjoy this hour together with us. So to starting, and as we already say, this is one of the 3 webinars that we will have in sequence. Each webinar will be connecting one to the other in order to give you a path that transfer some information on how Ocrim use and the principle that Ocrim use the technology on developing its own flow. This is a really technological section. So it's mostly dedicated to millers and production manager. But I think could be a good occasion also for the people which are not so familiar with the technological aspect that run in the flour mill to increase their knowledge and their expertise. Today, the topics that we will cover is more the stream granulation in the flow sheet and how this impacts roller mill and the purifier and roller mill. So let's see how these things moves on. Flow sheet, how to develop a flow sheet and what we need to develop a flow sheet. First thing is to have the proper information. So what we need for proper information? We need to have the well-defined specification of product. We have to know exactly what is the market demand and tradition. Sometimes just specifications are not enough to define the flower. So we need really to feel the market, and this is the reason why we say we need to have experience of the market. Then we need to know the market demand, of course, and the types of flour wheat that we will be grinding. Without this information, it becomes difficult to put together a flow sheet, at least a flow sheet that respects the expectation of the final customer that will produce the flour. As we mentioned, and before to starting any comparison, any evaluation, we need to understand why the market is consolidated and the reasons and what take a certain products be so important in certain market. And because without this evaluation, we cannot be effective on proposing something. So today, when we're talking about new tendency in the flour, we mainly considering three aspects, let's say, because two are correlated each other. The three aspects are low ash flour, so which is the flour, the tendency is to having a very low ash flour, which is correlated with the whiteness of the flour. So ash and whiteness of the flour. Then another tendency that we are seeing in worldwide is the granulation of the flour, so the demand is moving to very fine flour. And the last point is the rheological quality that has to be constant all the time. Doesn't matter if you have a very good flour sometime, but it's not constant. It's better to have a standard, a regular flour, but constant all the time, because this is what market is demanding. Industry is asking for constants, not for peaks. So it's important to have this and to focus on these four aspects. Today, our topics will be covering mostly the first three. So low ash flour, white flour, and fine flour, and how to obtain those products using our flow sheet. So together, when we say that there is a target to obtain, this target is the one that drives also the economical benefit or the turnover of the mill. Of course, if we exceed on extraction the flour that is most demanding in the market is the flour that will allow you to have more incoming, so increasing your turnover. And especially in these new flours for certain market, or for stable market that could be the Far East, the flour which respect this characteristic, which is low ash and whiteness and so on, are the flour that could make a very big difference in your turnover in the end. So it's important to have this aspect. Second one is also, if we are not able, or if the mill are not able to satisfy the new demand in the market, the mill will lose its competitivity and the strongness, because other one will take his place. So it's important to see this aspect all under all the complete point of view. But let us identify what we mean for low ash flour, because we say we need a very well-defined specification. Let us say what we are considering. For us, low ash flour is a flour with a ash content below than the 0.45. We are talking dry basis. If we compare these numbers on 14% moisture basis, we are talking below, having flour below than 0.4. When we say granulation or fine granulation, we mean that all this granulate, the flour has to pass through 118 microns. In some markets, this number could be even lower. There are markets that are requiring at least a fraction of flour below than the 90 microns. So, and this for hard wheat. For soft wheat, we have more or less the same granulation of flour, but the ash could be even lower, but even lower because the wheat will allow you to have lower ash content, okay? So, coming to the point, to achieve this target and exceed with the extraction of this product, and considering how is important this product in certain parts of the world, Ocrim developed a dedicated flow sheet for this, which we call the high efficiency flow. In our talking today, we will compare the high efficiency flow with the standard flow in order to see the difference and in the end to quantify those differences in order to be able to justify one flow sheet compared to another. So our talking today will be considering, of course, differences under the quantity and quality, the various points that we have to analyze, and also the basic concept that is behind and the flow which are developing, or the flow that we considering the high efficiency one. So, and those concepts, I would like to call those concepts as tips that you may use in your day-by-day life in order to also improve your existing flow and so on. So always when we say we are comparing something, it's better to identify the parameters that we are based on. And these are the parameters that define the two flows that we are comparing, the standard flow versus the high efficiency flow. The numbers are there. Grinding surface is between 12.5, 13. Sifting surface is 0.07 to 74, and purifier is 1.28, 1.32. Before to go in detail, someone could say that these numbers are a little bit generous, a little bit large, considering that in some area where the product to be produced is this white flour and this low ash flour, especially in Asia, mills with these parameters are considering at the border of the accessibility. So someone can complain, they want also large numbers, but let's compare these two mills based on this one. Another important concept that I would like to introduce, or at least to share, is the flexibility. Flexibility is something that you may need, especially in the new flour mills. So flexibility allows you to produce different types of flour, but also to grind any type of wheat. And we know that today the price of the wheat is one of the most important points. So having the possibility to grind in the best ratio between quality and price could be a very high advantage on your day-by-day production and so. Now, we will introduce the two flow sheets that we will be talking about. And what we are seeing now is the flow sheet related to the standard flow. Starting from that one, I would like to call your attention to one point which for us is important, and is one of the points that then we will speak more on details in order to explore more the differences between the two flow, and is the concentration of passages on the head of reduction, sizing and middling part. So this one will be one starting point for our evaluation on the next slide. One important thing, the evaluation that we are doing here on this group are the product that comes from the first three break passage, because they are the product that through the purifier will be able to produce the white or the low ash flour. So all our talking will be concentrated mainly on the product coming from this three passage on the breaking system to the head of the reduction. Now we will introduce the high efficiency flow. And from that, you can right away see the difference on the concentration of the passages. So you see already from that, just by feeling the difference that allow you to having more passages concentrate on the head of the reduction system to process the same product. Of course, this configuration will allow for a better distribution on sifter and in roller mill. And this is one of the concepts that we will stress. Just to make this data more clear in one data sheet, in one, for your reference, we are having here summarizing the passages on standard flow and high efficiency flow. And from that one, we are seeing that based on the same capacity of mill and more or less with the same grinding surface for the standard flow sheet, we have about 6 passages, and in the high efficiency flow, we are about 10 passages. Of course, with 10 passages, we have a different grinding. We can grinding more gentle, and this will help to preserve your product and the quality of your product. And this one is one of the aspects that will allow you to produce a high quality flour. Then, starting from this point, we want to start and considering how Ocrim develop its flow. So always we have to remember what we want for the flow sheet. So in our case, we want to have low ash and fine flour granulation, okay? And if we say, okay, if I have fine flour and low ash granulation, it's automatically, when I have one, I get the other one. Is really like that one? Is something that the statement is like that one, so low ash content drives for a fine granulation or vice versa. Let me say that in my opinion, in my experience, is not like that one. Unfortunately, if you want to have low ash with fine granulation, you have to be very careful on manage the product, because otherwise you will have the opposite result. If you want coarse product with low ash, maybe it's not so complicated. If you want to have fine product with no low ash, maybe it's not so difficult. But combining these two conditions could be quite a challenge. And we will see the reason why we have this challenge with the next concept, okay? So the reason why it's difficult combine lower ash with fine granulation is because when we have to produce fine flour, it's very easy to contaminate the flour with the bran fraction, because we the tendency is to grind strongly in order to make the flour finer. So we increase the pressure of the rolls, we reduce the distance on the smooth roll, so we try to grind too much. But this could have an impact. We can break the bran fractions, and breaking the bran fractions could drive you to a contamination on the flour. Also, it's important to understand another aspect, which is important, and we have to use this on our advantage. Bran and endosperm, they are two different products. And when we grinding, the response of the product will be different. So with the endosperm, when we grind it, the endosperm will be break in small parts, and we are able to reduce the endosperm on flour. because endosperm is more friable and breaks, let's say, quite easy. Vice versa, the bran is an elastic product. And when we pass through the roller mill, this elastic product will be flaked, so it will increase its dimension. Increasing its dimension will be easy to remove from the bran from the products by sifting by size, because we have a different size which create this difference on products. So the flour will be fine, the bran will be coarse, and we can remove it. This is a valid concept if we always make the properly setting in roller mill and in the sifter. How to do that one? We will see in the next slide, and we will see the concept behind that. We say on the previous that it's very easy to overgrind and contaminate the flour, because we overgrinding and we reduce bran in small parts that goes together with the flour. So this takes one concept already. We have to have clean product before grinding. So we have to grind just cleaned product. Today, the cleaned product can be obtained just through a purifier, which is the only equipment that today are able to clean the product. But of course, purifier is a very nice machine, but purifier has limits related to the aspiration, because purifier needs a strong aspiration that needs to be maintained. Purifier have increased the complexity of the mill, because we are adding other equipment which has to be maintained, has to be set, has to be checked, and so on. And also, purifier is a machine that does not allow for high capacity. It's a limited capacity machine, a flow rate. Just for your reference, we are sharing with you the capacity of purifier based on range, which is the first case between 1,600. We have about 2 tons per hour capacity of the machine. The range between 450, 300, it's about 1 ton. So this just to show how important is the granulation which is loading the machine. And this is an aspect that we will stress in the next part of our webinar, because the granulation is the key point that we base our high efficiency flow. Also because granulation impacts the flow rate of the machine, but also the product selection. What I mean the product selection? More finer is the granulation of the semolina, the product that we will clean, more difficult is for the semolina clean this product, because it's less the difference between the dirty parts compared to the white part. So less is the difference on the working of the purifier. Then also another aspect, working with the purifier, we will never have the product already ready to be converted 100% in flour. The purifier, and we will see the numbers later, okay, clean the product, but not up to the point where we are for the flour. So we'll never get 0.45 products from the purifier. This just as a reference. But we need the purifier, especially in the mills like that one. We cannot even thinking on produce low ash flour if we don't use the purifier. So purifier is a must, but we have to use the purifier at its best. Now, just to summarize and recalling what we said up to now, for a purifier working at its best, a granulation range is very important. So more closer is the granulation range, better will be the performance of the purifier, okay? Then, in the flow sheet, we have to consider a granulation range, but the granulation range is linked also to a quality aspect. We cannot mix products having the same granulation but different quality. What we mean for quality? Quality in that case is the hash range or hash value for a defined range. So if I have the same granulation, let's take an example, 1600, and in one case we have hash 0.5 and in another we have 0.8, is not a good thing mix these two granulation range, because we will impact the quality in the end. So this is the reason why Ocrim is so careful on defining the granulation of the product and keeping separate for quality and for granulation range. And this is another key point that we have and that we apply on the high efficiency flow. So now, Anna, I don't know if you have already some question or not, but let me hand over to you.
Yes, we have a couple of questions now. So have the concept listed for the HEF already been applied?
Yes, we have applied this one because this is a concept that is well accepted in Asia. Without a concept like that one, becomes really difficult to obtain the result that they are looking for. And you will see the result later on, how this impacts, because we will have really a standard flow with numbers that we have in the field, and a high efficiency flow, which are other numbers that we obtain from the field. So the answer is yes, we have both of these flow running, and today, for certain market, the only one that is accepted is the high efficiency flow.
Okay, another one. What about using of impact grinders compared to standard flow chart?
What's about using impact? Okay. Let's say on that one, this is a little bit out of our topics, but it's a good question because it introduces another variable. The impact machine breaks whatever it has the possibility to break. It's a different the way that the impact machine grinding. We say that in the roller mill, one of the proposal of the roller mill is to flake, and then we can split, we can separate the coarse from the fine through the sifter. With the impactors or with the impactors machine, we don't have this flexibility. So it's just the elasticity of the product that will resist a little bit more compared to the endosphere. So in other terms, we don't have the control on the breakage that we will have. So it's the machine that is playing its role. It's not the miller anymore that can play with the machine. Roller mills allow you to play with the setting, and you can obtain what you want. The impactors or the impactors, they will do what passing through will be breaking. Let's say on that one.
Mm-hmm.
Okay.
Another one. Okay. How about the extraction difference between HEF and SF with the same ash content?
We will see in the next slide. We will put together the extraction of the flour and the ashes that we will obtain. So I just ask for some more patience for a few minutes, and then we will see clearly indicate these numbers and why we get to these numbers. Okay.
Mm-hmm. Probably we have time for the last one question. If more gentle grinding is applied, what about the mechanical damaged starch?
Okay, let's say if you want to have a starch damage, you have to grinding with roller mills. So roller mills is the only machine that will allow you to produce starch. For example, when I say gentle grinding, I don't say that you don't have to grind strongly. Gentle means that you have to grind strongly when you can do it. You cannot grind strongly everywhere. So this is the reason why it's important to divide it in quality products in order to have this product. I don't know if I replied to your question, but this is the concept. We need to have clean product. As soon as we have clean product, we can grinding strong. If not, it's not good to have a strong grinding.
Okay, to my opinion, we should go on, and after we go on with the question and answer at the end. Okay,
so now let's see what is the basically concept that we apply in our high efficiency flow. Two of them we already introduced, which is the product distribution and the quality. So are the two main aspects that we try to keep considering all the flow. And the third one will be the cleaning through the roller mill. This is a concept that will be present on the next webinar, because this is a quite interesting concept that I would like to really stress a lot, dedicating one webinar just for that one. So you may say, okay, but there is nothing new on this concept that you are sharing with us. Yes, it's true, but you have to do it. You have to apply it, because by talking is easy, but how do you maintain the granulation distribution inside in the flow? How you maintain split the quality, or how you combine different products? So this is the secret, and this is the way that we have to create our flow, and this is what we try to identify later on with numbers, because in the end we have to have numbers. We have to have numbers proving what we are doing. Okay. As we say, the granulation is an important aspect and is essential concept, and this I think is clear for everybody. But the granulation is something that we can consider as a concept, a crossing concept. It's not a concept that has to be applied to purifier or other equipment. It's a concept that has to be applied to all the machine, even the roller mill. Of course, purifier is the machine that suffer a higher impact on the granulation, but even roller mill is a machine that could suffer the impact of the open wide granulation range. So saying that, and this is the reason why Ocrim is really careful about granulation, even granulation on the roller mills. Of course, the granulation in the roller mills will impact also the flour extraction on that roller mill. So we will put all these numbers together. Before, it's important to share with you the concept, because without understanding the concept, we cannot understand the numbers. So let's see how the granulation range impacts and the benefit that we have if we manage on the proper way the granulation range. Of course, we have the optimization of the setting of purifier and its performance. And I think purifier is quite close subject, because it's clear what we say up to now. But even the grinding is something that we can have a benefit, because if we have to grind on the same machine, coarse and fine, of course becomes difficult to understand how to setting the machine. So, and even how to set the sifter or related to the grinding that we have. Then increasing the number of steps, we have more flexibility. because if we get, like we show, if we grinding the same quantity in 10 passages instead of 6, we will have 10 different stream flour compared to the 6 stream flour. 10 different stream flours will allow you to better recombine flour if you need, because all these 10 flours will be different physically and rheologically. So there are markets that will appreciate this. Of course, if you don't need, there is no sense on complicated the flow. But here we are talking about certain specification that we have to match. And together with this specification, generally we have a recombined flour. Then, more granulation range, concentrate on granulation range we have, best is the configuration between roller mills and sifter, because the roller mill does one part of the job, the rest has to be done by the sifter. So it's important considering all these aspects. Now, the next step is how the granulation impacts the roller mill. And of course, impacts the quality, okay, impacts the product changing, but because if you're grinding more, what is the same example as before. What happens if we have coarse and fine and we grind hard in coarse and so we will create products, we can damage the product, okay? So higher is the homogeneity of the product loading the machine, better will be the final result, and better will be, easy will be also the grinding. Easy will be the grinding, and of course easy will be the setting. Less possibility of make mistake also, because if we have coarse and fine and we do a not properly adjustment, we can compromise the quality of the flour that we are which we are producing. And to show this, these two different, I would like to take these two examples, the two extreme cases, having the same product with a very open range of granulation, coarse and fine product, okay? Let's say I want to grind, to adjust the grinding for the fine products. What happened with the coarse? Of course, it will be will be an extra grinding. So it will be an excess stress. We will damage too much. With the consequence that some brown particles will be breaking down and maybe contaminate the flour. Vice versa, let's adjust the roller mill just for grinding a coarse product. What will happen in the fine? Maybe we could compromise the extraction, the final extraction, because the fine product will be not converted enough in flour. So these are the two extremes that we can be easily in. And when we have to put in this condition also the fine flour, okay, condition 1 is the one which on most of the cases we will be in, because the people try to tighten more. Then we have another question which can come. How is the ideal number of the granulation distribution? Let me say, granulation distribution depends for many aspects. Depends on the flow sheet setting, so what is the flow sheet that we have to develop, depends on plant capacity, depends on the equipment list, on number of passages. All these aspects are also related one to the other, but unfortunately, there is no a magic number. It's important for the company to identify what they have, what we have, what is the number of the equipment, and from that one, combine it what we have, considering that all these 4 points are part of the solution or are part of the answer that we have to give to the flow sheet. And To complete what we just say, this is an example for the standard flow compared to the high efficiency flow. In the standard flow, we have 3 main streams division. In the high efficiency flow, we have 4. We will follow these 3 and 4 ranges in many other aspects. But since from the beginning, it's important to say 3 groups makes more complicated the setting of the roller mill, as you can imagine. Less flower streams under quality and rheological point of view. Then also the quantity of the flower will be less compared to the other, because it's more easy to reduce a certain, a smaller, when you have a consolidated, a close range in flower compared to a large range. So, and another important point that we already speak about on the beginning is that those products are related, these talking are related just for the product coming from first to third break. So we are concentrated on the head of the head of the reduction. Let's introduce to this number, because we say, okay, more division also is more extraction. And this is the proving. Just to confirm you, those numbers comes from the real flour mill. It's not hypothesis, no. This is the real numbers that coming from a mill. So we can see that with the 3 passages, let's say with the 3 ranges, we have a certain extraction less compared to the 4 ranges. And this mainly because more homogeneous is the product going to the roller mill, more easy is to set the roller mill and increasing the flour extraction, okay? And now we will see some other concept that working on this way, having more passages, we can also respect more the quality ash, but also in the same condition, also the brightness of the color, which is keep clear. In other terms, more fractions we have, we will avoid to contaminate the flour. And of course, less contamination drives you to low ash flour with the higher extraction. So, and of course, we cannot thinking to having higher extraction or low ash flour working on products which is not from the head of the mill. Let's introduce now another aspect, which is the ash content of the product that loads the roller mill, and this is linking to the purifier. This is what I'm trying to say. We cannot convert all this product in flour because the ashes are already higher compared to what we want. But the advantage on working with the high efficiency flow is that the ashes are more concentrated. We can see we concentrate the ash on the first range, and all the others, they are already less on the four divisions compared to the 3. So this is a huge benefit because we can increase the extraction on these three flours or in the 3 streams where we have low ash. Okay, so the data evaluation tell us this: smaller is the particle size, lower is the ash content of the product, and this because the product went through more cleaning cycles. Okay, higher number of fractions create this gap between the higher and lower ash, which allow us to obtain more low ash flour. Then concentration, again, concentration is the driving aspect, because it's always better to concentrate ash in one passage, and then we're working properly this passage, and then the other one is easy to convert in flour. Those are, in very few words, the concept on dividing the flour, the streams on more flour, or the streams in higher number. Now, before to concluding, we already compare extraction. We already compare the ash contained on the loading products. So we already compare almost everything. Let us compare the flour ash contained that we obtain starting from a product as we see on the beginning, on the previous slide. So correlating the incoming product and the ash that we obtain with the extraction that we see on the beginning. So summarizing everything on that one, those numbers say us that the average flour that we have on high efficiency, on the standard flow is about 0.4. All numbers are on dry basis. The flour, the average flour that we are having on the high efficiency flow is 0.38. This with a higher extraction related to this group of flours. Then we will see the total extraction in the next webinar. One important thing, the difference that we are talking is about 5% in ash. So we reduce, with this system, we reduce the ash content about 5% comparing to the two flow. But in the same time, we increase the extraction. More or less for the evaluation that we did, the extraction has been increased about 8 to 10%. So these are the numbers that are saying, okay, we have just play on different way on the granulation, on the cleaning of the product, and then this is a result that we have. So to conclude, cleaning the semolina is a must. Granulation is another must to obtain this result. We cannot divide the two. So cleaning and granulation, one is helping the other. Then cleaning product leads you to have low ash product. And this is clear, but you have to have this one. You have to work to have as clean as possible the products inside your mill, or at least concentrate dirty products in one part and cleaning product in another. And this is one of the systems that Ocrim use in their own mill. So with that one, for today, we conclude. I hope we have some questions, but let me, since from now, invited you for the next webinar, which will be in the shortly, we will be informed the data. And I hope this hour together, this time together was helpful, at least to share some concept that we use day by day on the setting of the mill and so on. And I hope, which is more important for me, that you can use this concept in your day by day. So again, I hope to see you soon. And Anna, if we have some question, is your time.
Hi, Marco. Thank you very much for your clear presentation, also for me. And yes, we have some question. I go on with the first. What is the parameter of fine flour? Correlation with size micron, how to measure it?
This is the granulation of the flour is measured by sieving. So when we say the flour has 118 micron, this means that the 100% of the flour produced is below 118 microns. Or when we say 90, 100% of the flour is below 90 microns. So it's about granulation. It can be even lower, of course, because we will have fractions even below that.
Okay, there is normally quite a bit of dirt in the crease of the wheat, resulting in high ash flour for this passage. Will there be a benefit not to have a double roller stand for first break and second break?
Okay, let's say on that case, the area that the mill where we are talking about is not will not be affected on having double high on first and second break. So let's say your statement is correct. If we combine the flour between first break and second break, this flour will be contaminated. In a normal flow sheet, any flow sheet, if we have first and second break in two different or single high roller mill, the flour that you recover from first break will be higher in ash compared to the flour that you will recover on second break. But this is limited to that because the flour that we will produce in the regrinding system will come from the semolina that already passed through a cleaning process through the purifier. So it's important, and this is the reason why I'm saying that we have to properly treat the products coming from first, second, and third grade, because those products are the one that could give us this type of flour. Then, if we have a very good result on processing this, then we will have benefit on including also a little bit higher ash flour in the mixing. And in the overall, we can increase the ash, the extraction. But in the principle, you have to produce very low ash from the products coming from first, second, and third grade. Mm-hmm. Another point is that is important. Of course, more sophisticated is the mill, more logically is to avoid the double high. This is our philosophy. So if, for example, we are speaking to run or to develop a flow sheet with 15 millimeters grinding surface, there is no sense to use a double high. This is the concept, this is our concept.
Okay, probably we don't have so much time, so probably the last one. What happens when a purifier is overloaded? What happens when the granulation range is wide?
Okay, when the purifier is overloaded, it will be almost impossible to divide the light product from the heavy product. What I mean, purifier works by difference of density, okay? Difference of density related to the product, which is endosperm and briny parts. If we have a higher layer, this density will not be more easy to obtain through the air that pass through the machine. So this will create some compromises on the setting. And this is the reason why the machine will not properly work. The same happens for the open granulation range. But because it's a difference in weight from the endosperm particle and briny particle at the same size, because if we change the size, maybe the briny part could weigh more than the endosperm part. So this makes it complicated for the machine to select. This is the concept why we cannot overload the purifier, but in the same time, we have to close as much as possible the gap, the range for the machine, the range, the granulation range in loading of the machine. Otherwise, the selection will be not good enough to produce the flour that we are speaking about.
Okay, now no question, no answer, but just some sentences where the people tell you that you have been awesome, that everything was clear, and they thank you very much. So
thank you.
It was a pleasure listening to a very informative presentation, and go on.
And I hope they will continue to follow on the next, because the next one will be even more interesting.
Okay, we don't have any more time to answer to the questions, so you all the people can write us to conference room at ocrim.com, and you will receive the answer to your question. So thank you very much for your attention. Thank you very much, Marco, for your presentation, and I invite all to follow us in our social pages to keep updated to the date for the next webinar. Thank you very, very much.
Thank you to all. Bye-bye.